Hi, my name's Abe, and today we're going to talk about how to find tangents and normals of functions at some point. So first off, what is a tangent? So I'm sure you'll remember that if I have some line like this, call it f of x, and I have some point here, call that a, that the tangent is a line that goes through our point A, this point here, a line that goes through this point that has the same gradient as f of x at the point A. So it's got the same gradient, and it's going to be a straight line, right? So essentially you sort of measure out the gradient here, and it's just a straight line like so. Easy. Whoop, there we go. So that line there is a tangent. You see that it just touches f of x at the point x equals a. So very good. This line just represents, it's got the gradient of f of x at the point A, and also it passes through that line, that point f of A. So that's all well and good, but how do you go about finding a tangent? So first thing to keep in mind is this. Tangent is a straight line, right? And what's the equation of a straight line? Very simple. Y equals mx plus c. Now, we said before that the gradient of a tangent is what? The gradient of f of x at the point where you want to find that tangent, right? So m is actually equal to f dashed of a. So that's the gradient of f of x at x equals a, right? So that's the gradient of our curve, and you also know that it also must pass through, it's got to pass through a particular point. X equals a, y equals, well, whatever f of x equals at a, so f of a, like that, right? Okay, so we've got these two conditions on our tangent. Now, are these two conditions enough to determine our straight line? The answer is yes. For a straight line, what do you need? You need a point and a gradient. So this is a point, and the gradient, you might imagine, is this. So yeah, we have a point and a gradient. Simple, right? So that's enough information to determine our tangent. Let's do a very fast example. So, example here. Find the tangent of this function f of x equals log to the base e 4x cubed plus x at x equals 2. Okay? So we have some curve. I'm not even going to sketch it. On the exam you probably won't have time to sketch it. So yeah, some curve and some point where you want to find a tangent. Simple. Okay, the first thing you want to find is your gradient, right? Remember, we're doing a straight line, so you need a gradient and a point. So the gradient is going to be the gradient at f of x, where x equals 2. So the first thing you need to find is actually the derivative of f of x. So useful start, f dashed of x, sorry, wrong color. F dashed of x is equal to, so you know that for a log of some function, the derivative is the derivative of that inside function divided by the original inside function. And if you're not clear on this, feel free to look at my video on how to differentiate fast. So on the bottom you're going to have 4x cubed plus x on the top, you're going to have 12x squared plus 1. So that's f dash of x, right? And at x equals 2, f dash 2 is going to be 12 by 2 squared is 4 plus 1 over 4 by 2 cubed is 8 plus 2. It's just going to be 49 over 34. So immediately we know that in y equals mx plus c, m is going to be equal to 49 over 34. Simple. Alright. So now the point that we're interested in, right? We need to go through, so we know that the tangent, it has to go through this point. Like we set up here, a, f of a. So a in this case is 2, f of a, so you put a into our original function. Let's just quickly do f of a here. So f of 2 is log to the base e of 4 times 2 cubed is 8 plus x 2. So log 34. Alright, so 2, and the y value is log 34. And you don't need to worry too much about what that exactly is. We're just going through that point. Okay then. So far we have this. We have y equals 49 on 34x plus c. And to find c, what do? You sub in a point, right? Y and x. So you know that if y equals that, so y at this point is log base e, 34, equals 49 on 34 times, what's x? 2, plus c. And so c equals simply log to the base e of 34 minus, now 49 minus 49 over 34 times 2, which equals log to the base c of 34 minus 49 on 17. So multiply that by 2 is the same as divide the denominator by 2. Simple. Okay, so if we have c, that means we can just put in the total equation for the tangent. So totally we have y equals 49 on 34x plus log to the base c of 34 minus 49 over 17. Then our final answer. There you go. Not too hard. So what I want to stress is that this is a mechanical process, really. You're finding the equation of a straight line with a gradient and a point. The only tricky part is finding the gradient and perhaps the point. But none of this is particularly difficult. So yeah, very quickly, I want to talk about normals. Normals. So what is a normal? A normal, let's come back to our graph, draw a different color. A normal is this. Maybe I'll rub out this arrow. Oops, that's not rubbing out. There we go. The normal is basically similar to the tangent, but instead of being at exactly the same gradient as the point, as the function at that point, it actually runs at 90 degrees. So the normal does this, and it's at 90 degrees to the tangent. So for a normal, so let's label this the normal, right? So for the normal, again, you're finding a straight line. But here, instead of f dash of a as your gradient, what would your gradient be? Think back to maybe year 9, right? You learned that m1, m2 equals -1 if m1 and m2 are perpendicular. So in other words, the gradient of the normal and the gradient of the tangent, they're perpendicular, aren't they? So what you can write is that we can, how do I want to write this? Let's say I want to do mt, gradient of the tangent, times mn, gradient of the normal, that's -1, right? And we know that gradient of the tangent is going to be f dashed a. So essentially the gradient of f of x at the point a. So what we outlined up here. So if that were true, if that's the case, then the gradient of the normal is simply going to be, right, just do a little bit of algebra, -1 over m of the tangent, which is going to be -1 over f dashed a. So we see that for normals, again you're finding a straight line, but m equals -1 over f of a. So a, remember, is the point on the graph, so this part here. And the other condition is that we must pass through that same point that the gradient passed through. Oh, sorry, wrong color. Whoa. Okay, sorry about that. -1 on f of a, and we must pass through the same point as before. So a, f of a. A, f of a, by the way, if you haven't, if it's still not clear, that's just this point here. So yeah, and that's it. So you'd go through exactly the same process as for the tangent, except on the normal, you just find a different gradient. So yeah, no need to do an example on that. Again, it's very mechanical and fairly straightforward. So yeah, there it is, tangents and normals. Not very hard at all. Hope you've had a good time, and I'll see you next time.